Every achievement is not an end, but the beginning of a new journey. It all begins with an inspiration. Share yours with us at the SR Lounge. SR, let's begin.
Next up is another, as I said, an outrider of the kind of new worlds that we are going to be living in and occupying. This is Zach Smith. And he's going to present to us what's going to happen when individual choice becomes so immediate that if you want anything, you can 3D print it at home. This is the absolute outer edge of technological change. Please welcome Zach Smith.
Well, good afternoon, everyone. Thanks for having me. First off, can everybody just take a deep breath? I feel like there's been a lot of really heavy talks, like some really serious stuff. And I'm coming light and fluffy at you right here, right now. Like, I want to talk to you about my passion, about the thing that I love, and something that I think is changing the world in a way that's good. So I'm involved in building printers and robots, and we're trying to change the world for the better. So what we do, I've had a lot of chats with a lot of people here, and there's a lot of misconceptions about 3D printers. And what we make are tools. So humans have been using tools ever since we have started calling ourselves humans. It's in our nature to try and shape the world around us into something that's better than it was before. And so, you know, it started out with using sticks, and we evolved into stones and then metals and all these different technological progresses. And now we live in a world where we figured out how to automate stuff. And we have computers, and we can write programs, and they can be run automatically. And so what we're really doing is just building machines that are a creativity multiplier. So if you have an idea, we're trying to make it as easy as possible for you to take your idea for something and turn it into a real physical product. And that's really all it is in a nutshell. It just has a lot of fancy names attached to it. So to start off, what I want to do is kind of talk about the field in general. So we call this digital fabrication. This is the idea of using a computer, you design something, or maybe you 3D scan it, you get a file. You get a file that's similar to like a movie or an MP3 or something like that, but this contains data on the physical characteristics of an object. And then we have some sort of process. So with CNC, you're cutting away material, or with a 3D printer, you're adding material, but there's some sort of process that we figured out how to automate. We figured out how to have a computer do all of the hard work. And at the end, the whole goal of all of this is you get some sort of object. And I think the best way to understand this is just to see some videos. So this has been around for a long time, and this is kind of one of a really old technology, but it's also a really amazing technology. It's called selective laser sintering. You take a powdered material. This can be nylon, it can be ABS, it can be steel, titanium, and you take your 3D model, you slice it up into layers, and then for each layer, you have kind of this two-dimensional slice. And you take your laser, and you melt the powder for each layer. And then you roll another layer out over it, and you melt another one. And so here you have your model. It's slicing it up digitally in the software. And it takes each layer, and then here's inside the machine, you see there's a laser that's melting it down. And so about 4 or 5 years ago, I saw one of these machines, and I thought, that is amazing. How much is it? Can I get one? But this machine is like $300,000, so I can't afford one. And these these were used for rapid prototyping. They're used by big companies that want to make a new product, and they don't want to invest a lot of money. They just want to like try something out. And so I saw this and said, wait a second, it's not just for prototyping. You could use these machines to make real stuff. You could do all sorts of other things with it. And so we started a company called MakerBot to try and build a cheaper version, build a version that an individual could own, a version that you could have in your house instead of having to go to the university or have some sort of like corporate business plan behind it. And we succeeded in that. And so this laser sintering is a really interesting one because you can make stuff out of almost any sort of material. Any material that can be made into a powder and that can be melted, you can put in one of these machines and build all sorts of really advanced parts like this. It's used incredibly diverse applications all throughout the industry for decoration, for product development. NASA just was building rocket engines with this kind of stuff. So it's one of those technologies that's really powerful and is very widespread. It's kind of the secret technology because it's not the kind of thing that gets written up a lot. And it's also really expensive. Like there's maybe a few thousand of these machines in the world. So this next technology is much more accessible. Laser cutting is one of those things that has literally changed my life. When we built MakerBot, all we had access to was a laser cutter. And this one in this particular video is laser cutting steel, but any sort of material that you can get in a flat sheet, you can pretty much cut with a laser. And this is really nice because we were able to, we had a group of about 20 of our friends, and we pitched in, and we all put in a little bit of money, and we were able to get kind of a low-end laser cutter. But through this, we were able to start a $400 million business because we had this tool, and this tool allowed us to do things that we could never have done before. We could do our designs on the computer and then go to the laser and use it. And so, I love these machines, and they're just beautiful to watch. The way this works is it's basically a machine with a laser on it, and the laser is powerful enough to vaporize whatever you shoot it at, and so then the computer just moves it around. And so this is, if you're a designer, if you are comfortable working with graphic design tools like Photoshop or any of the vector-based design tools, a laser cutter is really awesome tool for you because the way you use it is you basically open up your design in Illustrator, and wherever there's a line, when you hit print, it goes to the laser cutter it shows up as a printer. You hit print, and then the laser cuts it out for you. And it can do this all day, all night, and build these amazingly intricate shapes that even if you trained for years and years and years, you could never do this by hand. And so, when we talk about a creativity multiplier, it means it's much easier for you to get that amazingly intricate shape out of your head and into the real world. So I love lasers. And plus, they have lasers on them, so I'm kind of, I love that part. You're vaporizing the material. So this is a time-lapse of the technology that we created, and there's actually a machine sitting right next to me that's printing one real time. It's a 3D printer. So the concept behind this is you basically have a really fancy hot glue gun. So I'm sure we've all played arts and crafts, used a hot glue gun, you press the trigger, and a little bit of plastic comes out the tip. Well, we figured out how to automate this and have a computer-controlled head that moves around and draws a single layer. And then when it's done with that layer, it drops down a tenth of a millimeter, and it draws the next layer. And so over time, what it does is it builds up this layer after layer after layer, and at the end, you're left with a real physical object that came from the computer. And because we've done this and put it out there, MakerBot was one of the very first companies out there building desktop 3D printers. Our first printer was $600. We've since realized it takes a lot more to build a 3D printer, so now they're around the $2,000 range. But this is orders of magnitude cheaper than what you could get in the past. And what we've seen is that if you look at just the pure numbers of units of 3D printers, MakerBot is the biggest 3D printer manufacturer in the world. We've shipped close to 100,000 units, and that just kind of blows away all of the high-end machines because people are actually getting access to this. They're in schools, they're in homes, they're in hacker spaces. Engineers can have them right on their desk right there to use. They don't need to go through any sort of process to build something cooler. And people are building businesses around them, which I find to be just the most satisfying thing I can imagine, is meeting people that have an idea, but they come from a background like mine. Like I came from middle-class Iowa in the States, farmland and all that. And when I got access to a laser cutter, it allowed me to make my dreams come true. It allowed me to take this out of my head and make it a reality. And so for me to be able to give that and pass that on to other people is just really, really magical. So this one is kind of like the underdog of digital fabrication, but it's also the oldest. I don't know why it's not as sexy in the minds of the media, but it's CNC. You take a chunk of material and you cut away. Like you get like this big tool and that's spinning and is dangerous, and it follows this path automatically. And here it's making something out of aluminum. And you can work with all sorts of different materials and all sorts of everything from steel to plastic to wax. And it's funny because this is one of those tools that's been around since like the 50s. And if you go on factory visits, and I've been in a ton of factories, it's like the workhorse. Like all of these different processes, like every single consumer device has an injection molded part on it. Like they use CNCs to make the molds to do it. And that's actually what this thing is doing here. It's making a mold for like a quadcopter case. And it's one of those processes that is really nice. It's not quite as flexible as 3D printing because you have a head, you have like a cutting bit, and if it can't fit in the right place, then you can't make that feature. But it is extremely useful, and I guess what I'm trying to say is 3D printing is kind of the poster child for this idea of digital fabrication, this revolution of, hey, we can have robots do the work because they're going to be a lot more accurate, they can work 24 hours a day, and it's going to allow our designers and engineers to work at a much higher level than they have been in the past. And it's just really nice to watch. I'm going to get distracted up here, like just watching this video on the monitor. So yeah. And then so robots, I tell people I build robots, and in my mind, a robot is some sort of computer-controlled device that interacts in the physical world. So this is a robot here because it has actuators and it's doing something. I've asked this robot to make me a part, which I'll show you at the end, so you got to stick around. But this is kind of more of a typical, what you would imagine is a robot. So this is a robot arm, and you start to see it come down here in the picture. And these are kind of a newish sort of technology that are insanely popular in the industrial manufacturing space. So they can be configured to do all sorts of different things. In this one, it's acting just like a CNC, just like what we saw. But these things are used to weld cars. They're used to pick things up and put them in different places. And this is kind of one of those technologies that is extremely adaptable and is really going to cause big changes in the future. I'm predicting that these things, right now they're very expensive. You can get one of these for maybe $30,000, but there's people working on making them much cheaper. And one of the big challenges is software to control these. They're rather complex, but the huge advantage of this thing here is that it can be programmed to do all sorts of different things. So this thing is just cutting away material, but it could just as easily put down that cutting tool, grab a 3D printer tool, and do something with that. Or it could put the 3D printer tool down, grab the thing that it just finished, put it over in a bin that is for all the finished parts, and then start doing something else. So these are kind of in the realm of tools that have lots of potential. This one is way up there. And plus, it's just really nice to watch and see it. It can just make amazingly intricate shapes, and all of these tools have this sort of shared aspect that they run off of software. There's some sort of source file that someone designed, and so they're making a propeller or a mold for a propeller in this video. But after they do it, if they find that that wasn't quite right, they can just make whatever change they need in the software and run this program again, and it'll make another copy of it. And so, you know, it gives you the sense of being able to just make revisions. And just like if you're a software developer and you write some code and you find out there's a bug in your code, you know, you don't write a whole new program to fix that bug. You go in there and you fix it in the source, and then from there on out, every time you run the program, it's fixed. And so this very similar thing happens with 3D printing, with digital fabrication, where you have the source code for your object, and then you have some sort of process that turns it into a physical thing. And so 3D printing is the main topic of this chat, and so, you know, it's gotten really cheap lately, and this is the cheapest 3D printer I've ever seen. It uses a different technology than what we were using at MakerBot. These guys use a liquid, a resin, that when you hit it with laser light, it solidifies. And so they figured out a way to make a machine about this big, and for $100, $100 US, you have a machine that can make you things. And this is just going to put 3D printing in the hands of so many people. It's not even funny. Like, this is one of those really game-changing kind of things. You know, the quality is not the best. They just launched a few weeks ago on Kickstarter, but that's the kind of thing that they'll be able to address. And these guys raised, I think, close to $1 million. So the desire and the demand out there for people that want access to this technology, I mean, you know, I'm up here saying, hey, you know, $2,000 printers, that's really cheap. But, you know, I know for a lot of people, like when I was in college, $2,000 was not cheap. You know, $100 is not even cheap. But it's so much cheaper than it was before. And, you know, I'm a firm believer of when you put tools in the hands of people that have ideas and have creativity, it really just helps them make a better life for themselves. So I like to kind of draw a parallel between the world of computing and the world of digital fabrication, because there's a really good one. Before we had laptops and cell phones and computers, these things started out as mainframes. They started out as these big business machines for keeping track of payroll and doing all the boring calculations of running a business. But then something came along. Steve Jobs and Wozniak, they said, hey, you know, this could be really cool. I'm sure normal people could find a use for this too. And they said, but we need to make it cheap. We need to make it personal. We need to make it something that can fit on your desk. And so that's what we did with 3D printing, with MakerBot. We said, you know, these big machines, they're so cool. And it's funny, because when we first started doing it, people would ask us, well, what are you going to use this for? And I didn't really have a good answer for that, because I knew that there were other people out there who were more creative than I was, who had ideas, who had art projects, who wanted to make something cool, but they didn't have the right tools to bring it into reality. And so, you know, we were able to help with that. And, you know, in many ways, we were lucky. We were in the right place at the right time with the right idea. But there's a few things that are really contributing to this change. The first one is that the cost of computing is dropping rapidly. Thanks to the smartphone wars, I think Chris Anderson said, cheap computing power is the peace dividend of the smartphone wars, meaning because there's this explosion in all these advanced consumer devices, the cost of those components has dropped quite a bit because there's just huge volumes and huge scales involved. So we were able to add all sorts of really smart electronics in here to do this that would 10 years ago would have just been impossible. Another thing that is great is like a majority of the early patents on this technology, the patent that says 3D printing is this, those are all starting to expire, and in the case of MakerBot, they had expired. So we were able to come in and say, okay, you guys had your 20 years to make these giant, expensive machines. We're going to take this to the masses. We're going to say, now everyone can have access to this. And the third is technology itself is improving. There's been a lot of research into materials, into control systems. Motors are really cheap. So, the stars have sort of aligned for this revolution in manufacturing. Another thing that has happened is the internet. So we've come up with a way to automate the transfer of information. So we figured out how to digitize all of these things that we use on a day-to-day basis. We figured out how to digitize music, movies, articles, books, all of these other things. And it basically costs me nothing to send an email or send a video to someone else on the internet. And so what this is doing is we found a way to digitize real things, like real objects. We found a way to say, this is the DNA, this is the source for an object, and now you can do all the things you do with it on the internet. And one of the things I'm extremely proud of at MakerBot is we built a site called Thingiverse, which is a site that has about 100,000 freely downloadable designs that if you have a 3D printer, go on the website, you find something you like, whether that's a beautiful piece of art, something for your house, or even something like this. There's a project called OpenHand, and OpenHand is an open source 3D printable prosthetic. So let me just let that sink in for a second. It's the kind of thing, like prosthetics are typically either really cheap and really awful, or they're really expensive and very full-featured. But these guys have decided to use 3D printing to build customized open-source prosthetics. And so they managed to drop the price of one of these prosthetics from thousands of dollars down to a few $100. And we're not talking like a club with a claw on it. We're talking like fully articulated fingers that can attach with electrodes so you can grab stuff with your prosthetic arm. And this is just one of thousands of things like that on the internet. Everyone with an idea for some sort of hardware thing that they want to make, and if they're interested in sharing it, is capable of doing that. And so the beautiful thing about this is because it's digital, because it's cheap to share, because copying costs nothing, you're able to harness all of the wonderful benefits of open source. So, to give an example, I have a bottle of water. If I give this bottle of water to someone else, I no longer have the bottle of water. But if I give someone the design for the bottle, I can have my own bottle, they can print out their own, and if that design is sharely free, oh my God. Okay, the point is this, because the design is shared, if people make changes, they can share it back with everyone else, and then everyone benefits, and there's very little negative or very little loss for anybody else. There's very little disincentive to share. And so we've seen a huge explosion of open source projects and things like this, where there's dozens of 3D printers that their designs themselves are open. So I was kind of alluding to this earlier, the idea of you have a machine, it's on your desktop, it can make you whatever you want. And one of those things that people like to do with this is follow their dreams. So, and for a lot of people that is, I don't want to work for someone else. I have my own beautiful ideas, and I want to get those to other people. And so I ran into this guy. His name is Hanbao. And so Hanbao has this dream of being able to go on a run and listen to his music, but he doesn't like headphones. And so he wanted to take a Bluetooth music player and some speakers and put it into his sweatshirt. And if you wanted to do this and make it previously, you basically had to go to a factory and say, hey, here's my designs, can you make me some molds so we can mold these things? But instead, he used his 3D printer, and he was able to print out the little plastic pieces that kind of tied everything together, and he was able to make the hoodie, so he had one for himself, but he was also able to launch a business around it. And so now he is online, he's selling these things. He's based in Shenzhen, so it's kind of a local China thing. But I've ran into dozens of things like that. So there's all sorts of people out there who are saying, you know, I have this amazing idea. I want to share it with the world. And you know, there's no longer a gatekeeper, right? So getting access to a 3D printer is really easy. There's hacker spaces all over the world. There's community maker spaces, you know, and these things are out there. And what I love is that you don't have to get permission from someone to go after your idea. You know, this guy didn't have to get approval from anyone to go after this. Like, the cost of materials, the cost for him to develop this thing was you know, maybe $100. And, you know, if your dream is not worth $100, then, you know, you should find a new dream, right? Because this, like, it's possible, and there's so many ways to go after it. So this is where we get into the science fiction part of the talk. I mean, I love science fiction, and it's one of the inspirations for the things that I do. And this is actually the project that got me into 3D printing in general. So the name is RepRap, and the idea is that if you really want to make 3D printers accessible, a great way to do that would be to have a 3D printer that can make a copy of itself. And now this is an audacious goal. I mean, nobody's saying this like, oh yeah, we'll have that done by next week. But it's one of those goals that says, you know, if we can get this technology to the point where it's good enough to make a complete copy of itself, then anybody that wants one, all they have to provide are the materials and the energy to do it. And then all of a sudden you have all of these tools of productions, the means of productions, available to anybody that wants it. Anybody that wants to build things for their houses, anyone that wants to make a new business, anyone that wants to build something amazing can get a hold of this. And this whole project was done as open source. And you know, it has achieved the design of self-replication pretty well. You know, as you can see on this image, there's still quite a few things in here that are metal. There's electronics that can't be made. But what it has done, as kind of a side effect of the whole, hey, we figured out how to make a 3D printer that makes most of itself, is there's a huge amount of technology in this that has been published and allowed people to build other machines. These are a huge part of school curriculum, teaching kids engineering, how mechanical systems work, how materials work, just things of that nature. And you know, I love this project because it is very inclusive. It's all freely available on the internet. There's a community of people that, if you want to build these, you know, you can find someone online that will print you the parts. And you know, it's one of those things that people just are really passionate about, and they want to share this thing. They want this to get out in the world. They want to provide the tools to other people. And so this is kind of the thing that I'm excited about. You know, I want to live in a world where we are no longer just on one planet. I mean, first of all, it's dangerous. Like, as we've seen today, like, humans make all sorts of mistakes, and like, there's a pretty good chance we're going to ruin it all, you know? And that sucks. So if we ever hope to get beyond that, if we want to go to Mars, or if we want to go to the moon, you know, it is just not feasible to send everything we need from Earth to there. So in order for it to actually work, if we want to make a viable colony somewhere else that's not Earth, we're going to need some way of making the things that we need in the place that we need them. And so for me, I think that a big part of that is going to be 3D printing, digital fabrication. If you can fit a small enough, you know, I think of it as like a seed, right? So a seed has all the things inside of it that it needs to turn into a tree. And if we figure out how to do that with our technology, then we could send a seed all the way to Mars, or we could send it to the moon. And that seed could automatically build all the things that we need. Everything from habitats to the tools to do whatever it is people are going to do on the moon. You know, there's a lot of stuff. And if we get to that point, it means that we'll have that technology here on Earth as well. You know, a huge problem in so many developing countries is just getting access to shelter. And you know, if we can find ways to do that better, if we can find ways to do that cheaper, I know there are people working on 3D printers that could build houses. Right now, I'm not really an architect, but I imagine a huge part of the cost of building the house is the labor involved, is getting everything together, doing it right. I imagine you need to have some sort of skilled labor involved in making sure that the house doesn't fall over, that it's built properly. And that's something that robots are really good at. They're good at following instructions. They're good at saying, OK, this brick goes here, and you need this much mortar going between it. And I think that it's one of those promising areas. And this is also, the world of 3D printing is really, it's a frontier, right? It's one of those areas of science and technology that is not finished. We're nowhere near close to being done. I mean, this is, the thing that everyone raves about is a thing that makes stuff out of plastic. And our dream, the dream that people have with 3D printing is taking your idea, and your ideas aren't just plastic. People have ideas about electronics, they have ideas that deal in all sorts of other materials, and somewhere in the future, someone's going to figure out a way to make multi-material things and really high quality and make it really cheap. And so what I want is for you guys to think. This place is called Think, so here's my questions for you. What if everybody in the world had the tools they needed to make their dreams into reality? What if people, instead of hoarding their ideas and saying, no, this is mine, I own this, this is an idea, you can't have it, oh, you heard it? Shit, give that back to me. And what if you don't need to be a skilled craftsman to make something? I mean, when I first started getting into this, I was trying to build a 3D printer, and I was drilling holes in wood. I'm a computer programmer. I can't drill holes in wood. It didn't work. But with a machine like this, you can say, OK, I know that certain holes should go in this place, and then the robot can help you make that happen. And yeah, once again, thank you for having me. And before I go, I just want to show. We just 3D printed this whistle in the machine while I was talking. Thanks, everyone.